Subscribe to our channel and click on the bell icon so that you don't miss out on our updates and get notified about our new videos.
Suppose I have a vector A which consists of 10 elements, 1 to 10, and I want to find out all the elements in A which is greater than 5. I would use this command, A of A greater than 5. So I would get all the elements which is greater than 5. If I want, I can as well store them into B. B equals to A of A greater than 5, and B would consist of only those elements in A which is greater than 5. I can as well use A greater than 5. This will give me a logical vector. When I say A greater than 5, instead of A greater than 5, I would get a logical vector to say, is the first element in my vector greater than 5? It's false. Is my second element greater than 5? It's false. Is my third element greater than 5? It's false. And if you see, from the fifth element onwards, that is starting from 6, 7, 8, 9, and 10, I would be getting true for everything. So if you just use this command A greater than 5, you're going to be getting a logical vector. If you want, you can as well store this into a new vector. Now C would be a logical vector. Let's try to find out the min and max elements in the vector A. We know that our vector A consists of 10 elements, and if I say min of A is 1, and if I say max of A, they are built-in functions which will give me the min and max elements. If I want, I can as well store them into a new variable. I can say B is equal to min of A. Now B would consist of 1. Similarly, I can also store the output of max of A into another variable. There's another interesting function called as which allows me to find out which element or the position of the element in a given vector, which is the maximum or which is the minimum. So I would say which dot max of A, which simply gives me the position. So the 10th element in my vector A has the maximum value. To make it more intuitive, I shall recreate the vector A with the values defined by the user. I would say 1, I would say 100, then I would say 5, 56, and then I would say minus 5. So clearly the second element consists of the largest value, and the last element or the fifth element consists of the smallest value. So now which dot max of A would give me the number as 2, and which dot min of A would give me 5, which means minus 5, which is present in the fifth location of this vector A, is consisting of the smallest value. So this is a function which can be combined with max. Max and min can work as a standalone function, and this which function can be combined with the max and min functions. Suppose I have created two vectors, vector A and vector B. Now vector A consists of numbers ranging from 1 to 6, and vector B consists of numbers ranging from 5 to 10. When I use this function called as is.element of 1 comma A, will simply check if my element 1 is present in my vector A. Of course, my vector A is consisting of 1, 2, 3, 4, 5, 6, and it should result in true, which says it is present. If I check is element 10 present in my vector A, obviously my vector A doesn't consist of an element called 10, so it should result in false. So this is the use of is.element. We can check if any given element is present in our vector. Interestingly, we know that A is a vector consisting of numbers from 1 to 6, and B is another vector consisting of numbers from 5 to 10. I can as well use is.element A comma B, which will result in a logical vector which says, or which checks if every element of A is present in B or not. Meaning what it does is it takes 1 and checks if 1 is present in vector B. False. Similarly, 2. Is it present in vector B? It would say false. 3. Is it present in vector B? False. So on. So once it reaches 6, it will say true. So every element of vector A will be checked if it is present in vector B. That is what is dot element of A comma B. So we got a logical vector whose length will be equal to the length of the original vector here, the first argument in is dot element. So is dot element not only takes the argument as a number, it can also take the argument which is a vector itself. Now we know that our vector A consists of numbers 1 to 6. Let me modify that to a consisting of 10 numbers. Now vector A consists of 10 numbers. Now there is a sample function which actually obtains a random sample from vector A. So it got a random sample.
Hey, thanks for watching. Do like the video, share it, and also don't forget to subscribe to our channel for more such videos. Check out exclusive coupon codes for our YouTube learners in the description and visit manipalprolearn.com to redeem it.